In this video, I just want to quickly show a proof for why the derivative of the natural log of x is equal to 1 over x. So this statement here is what I want to prove. So let's start by writing out, we're going to say the derivative of the natural log of x. And what we're going to do here is we are going to rewrite this derivative statement using the formal definition of the derivative using the limit of the difference quotient. So I'm going to write this as the limit as delta x, or the change in x, approaches 0. And so we're going to write this as natural log of x plus delta x minus the natural log of x, all of this over delta x. And all I'm doing again is using the definition of the limit definition of the derivative here. So I'm just rewriting that statement. So since I've got that, I'm just going to keep working on this side over here. So I've got delta x approaches 0. And I'm actually going to use a log property here. Let me just write that. I'm going to use a log property. And the specific log property that I'm using here, we notice that we're taking the natural log. We have the difference of two natural logs. So this says the natural log of a minus the natural log of b. This is equivalent to the natural log of a over b. So what I can then do is rewrite this as the natural log of x plus delta x, all of this over x. And this entire natural log then is written over delta x here. All right, so I can then, and I'm going to write this in one step, but hopefully I'll show you kind of what I'm doing here before. So I'm going to rewrite this delta x. I'm going to rewrite it as 1 over delta x times all of this, the natural log of 1 plus delta x over x. Well, why am I doing that? Because I can use another logarithmic property here. I can then say, let me actually make some space. Let me move all of this stuff over here. So I'm working more. So I can then rewrite this using another log property, which would be the natural log of 1 plus delta x over x. Where did that 1 over delta x go? I'm effectively taking this and I'm rewriting it as a power of this argument. That's another log property. We can say the other log property that we're using here is to say that a times the natural log of b is equal to the natural log of b to the a power. So I'm rewriting that as 1 over delta x. That is now a power of my argument, 1 plus delta x over x. Okay. Now this next part here is something that many probably wouldn't think to do, but I'm going to use a change of variable here. And the reason why I have to do this is, well, I don't know if I actually have to do it, but I'm going to do it because this allows me to make a number of important and necessary substitutions so that we can actually see the structure that we're kind of aiming for. And hopefully that'll make sense in just a moment. So I'm going to redefine this delta x over x as n, as just some other arbitrary variable. I'm just going to call n. So n is equal to delta x over x. Well, if that's the case, I can then say that delta x is equal to n times x. All I did was multiply both sides here by my denominator. And then I can write the reciprocal of this, 1 over delta x, which is what we see over here. 1 over delta x then would have to be equal to 1 over n x, which is equivalent to 1 over n times 1 over x. Okay? So I've just redefined a couple of variables here, which I'm now going to make the substitutions. So what I'm effectively saying now is the following. Well, let me actually do this in a different color. I can say now, as x, or delta x, excuse me, approaches infinity, that's equivalent to saying n approaches, excuse me, not infinity, I apologize. As delta x approaches 0, that's equivalent to saying that n must be approaching 0. Go to think at this statement here. As delta x is getting closer and closer to 0, n must also be getting closer and closer to 0. So I can then make the following substitutions. I could say, instead of writing this as the limit as delta x approaches 0, I can write an equivalent limit statement. Find the limit as n approaches 0 of the natural log, and I'm going to rewrite a bunch of this now in terms of n. I'm going to write 1 plus, and again, we said that delta x over x, all of this is equal to n, so this is plus n. And we're raising this to the 1 over delta x power, which we redefined here, okay, as 1 over n times 1 over x. So we're raising this to the 1 over n times 1 over x power, okay? So just to be clear, this is the natural log of this entire argument here. Well, just like we did before, we are going to then we can move this power over to the front. And why am I not moving that 1 over n? Hopefully you'll see, it'll make more sense in a second, but I can see that this limit is a limit of n as n approaches 0. So really, finding the limit of this as n approaches 0 has no bearing on 1 over x, or maybe I should say 1 over x has no bearing on what this limit is. So I kind of want to actually just move it out of the way. So I'm just going to, first off, write it as this, as an intermediary step so you can see it, the natural log of 1 plus n to the 1 over n power. And again, because this 1 over x here has no bearing on the limit, since I'm taking the limit as n approaches 0, I can then move that 1 over x to the front and write this as the limit as n approaches 0 of the natural log of 1 plus n to the 1 over n power. All right, so now this is the part where you should start seeing the structure, and hopefully you're starting to get a little intrigued here because you may have an inkling of what's happening. Ask yourself here, does this look at all familiar to you? What do we know about the limit of this as n approaches infinity? Or actually, make it even a little bit more clear. I can even move the limit to the inside of this. This is an equivalent limit statement. Maybe this will really hopefully hammer this home. If I take since I'm taking the limit as n approaches 0, I can look at it as this. And ask yourself, the limit as n approaches 0, does this look at all familiar to you? And yes, this is actually, let me do this in a different color here. This is the alternate definition of E. This is how we define E. It's one of the ways of defining E. What is 1 plus n? 1 plus n as 1 plus n raised to the 1 over n power. What is that as n gets closer and closer to 0? Well, that's exactly equal to E. So that's the case, and then we can write all of this here as 1 over x times the natural log of E. And the natural log of E is simply 1. So we have just shown that the derivative, let me just zoom out here so we can all see all that. I know it looks like a pretty extensive proof, but the derivative of the natural log of x is indeed equal to 1 over x. Now, we can then use this bit of information to start finding the derivatives of natural log functions, which we'll do in the next video.